Hello everyone, my name is Napasai Sutishitipong. In this presentation, I am going to discuss various methods of visualizing and analyzing time series data, including autoregression, moving average, exponential smoothing, autoregressive integrated moving average or ARIMA. First, we will have to explore what is time series data. Time series data is a collection of data continuously over time, means there is always a time axis in the graph, as you can see. There is time and time is but it's not shown. Time series data can be in many forms, for instance, daily, weekly, monthly, or yearly. The example of time series data in real life are sales per week, stock data, weather data, or for the obvious example, the COVID-19 patient data. So time series data can be useful in many ways, such as weather tracking, forecasting, visualizing medical data, but in fact we will use them in terms of economics, such as to predict sales or stock. So let's get into first technique, exponential smoothing. This technique is used to smoothen the graph of time series data. It uses weighted average to predict new values based on previous observations, meaning that as we move further in time from older observations, the difference of this observation decreases, and there are three different types of exponential smoothing, which are simple exponential smoothing, double exponential smoothing, and triple exponential smoothing. So, simple exponential smoothing predicts value based on this formula without trend or seasonal factor, and alpha is a smoothing factor that determines how much importance will be given with respect to prior observations. The value is typically set to be in the range between 0 and 1. Intuitively, the higher the smoothing factor, the time series graph will tend towards the original graph. However, when the smaller value of the smoothing factor is taken into the calculation, the smoother the time series graph will be. Double exponential smoothing predicts value based on this formula with a potential trend but without a seasonal factor. There are now two smoothing factors included in this exponential smoothing technique. The definition for alpha smoothing is the same as in simple exponential smoothing, but however, beta is another smoothing factor for the trend. This value beta is also between 0 and 1. Next, triple exponential smoothing predicts value based on this formula with a potential trend and a seasonal factor. But in addition to the two previous smoothing factors, gamma is a smoothing factor for the seasonality. But for exponential smoothing, triple exponential smoothing is complicated, so we don't talk about it much. So let's move to next, moving average. This technique is used to smoothing the graph of time series data. We use moving average to help identify the trend of direction. Moving average can be calculated by using the previous specific range of data set window or window. For example, If we want to find trend of stock closing price by using previous data of 5 days, we will sum the price backward for 5 days and calculate the average as follows. As you can see, that there is no value for of moving average for the first 4 days, since there is not enough data to calculate. And there are two basic and commonly used moving average. First is simple moving average, calculate the arithmetic mean of a value over a number of time periods, which are shown before. And second, exponential moving average, calculate the arithmetic mean of a value over a number of time periods, but give higher weight to recent values. Basically, exponential moving average is more effective than simple moving average, since the recent data seems likely to have more influence. Next, we move to autoregression. Autoregression is a kind of linear regression model. Auto means self, and it is a regression that includes previous data of itself as predictors, meaning that we assume the current data depends on its previous values with some lag. Linear regression works best when the predictors are uncorrelated. From this knowledge, we can plot and see if many numbers of lags are positively correlated. Then we would know we need to differentiate our data. And next, ARIMA or autoregressive integrated moving average. ARIMA forecasting is a combination of AR and MA to create a more complex model that can work with time series data that exhibit characteristics of non-stationarity and seasonality. As mentioned in earlier section, ARIMA is still a linear regression model. It will work best when predictors are not correlated or independent. To make our predictors independent of each other, we need to make it stationary. So plotting autocorrelation can help us visualize how dependent our predictors are. If there is high autocorrelation for many number of lags, then we need to differentiate it to make it more stationary. And after all of this, I am going to demonstrate the implementation of this technique with a data set of COVID-19 time series data on Jupyter Python. So the first part is data exploration. I have COVID-19 confirmed and recovered. As you can see, the dimension that are provided are province, country, latitude, longitude, and date, starting from 2020. And when I check the numbers of column, it seems to be have link. It seems to be 122 columns, which quite a lot. So we have to pre-processing with it. Let's get into the pre-processing part. So first, we are going to drop latitude and longitude dimensions because they are not necessary for the prediction. As you can see that we drop it at this. And next, we're gonna group countries together because of some countries were separated into many provinces, and after that we will transpose the column and row to minimize column and rename the axis to date to make it proper match the actual data, and the pre-processing part is done. So no, not yet. But lastly, the data is cumulative data. So I chose to use the cumulation function to make it non-cumulative data so we can use it properly. And next is exponential smoothing part. In this part, we're going to use just simple exponential smoothing and double exponential smoothing because the triple exponential smoothing use seasonality, and I don't think this data set has seasonality. Okay, so these graphs show time series of total confirmed and recovered COVID-19 cases in Thailand, with the implementation of a simple exponential smoothing technique with the date as x-axis and the cumulative number of cases as y-axis using alpha 0.05 and 0.3. And these graphs show the time series data, the total number confirmed and recovered COVID-19 cases in Thailand with the implementation of a double exponential smoothing technique with the date as x-axis and cumulative number of cases as y-axis using alpha 0.9 and 0.02 and beta 0.9 and 0.02. So you can see that the graph after smoothing is quite smooth, as you can see in this yellow and blue, dark blue. So next is moving average part. This is also a pre-processing part. We use simple moving average for the sake of simplicity, as you can see that I set the window to 15 and 30 to show the difference between using backward data 15 and 30 days. As you can see, it's quite different. And next is auto regression. So let's skip the pre-processing. As you can see, the dark horizontal line at 0 has just denotes the 0 line. The lighter full horizontal line is the 95% confidence level, and the dashed horizontal lines are 99 confidence levels, which means that the correlation are more significant if they occur at those levels. There is an implementation of auto-reg from stat models show auto-regression forecasting for the next 2 weeks, as you can see here. And after performing auto-regression on the data, it show the difference between the prediction and the real past data. Then the reason I chose 7 to be the lag value is because there seems to be seasonality in the cycle of a week, as you can see that. And so lastly is ARIMA. From the graph, we can see that at first order of differencing, only the first and second leg has high autocorrelation, means that our data is stationary at order of difference d equal 1. After plotting many correlations, I decided to choose the rest of parameters to 1. So P, D, and Q parameter is also 1. And finally, we have the result of prediction of ARIMA model. As you can see, it seems to be precise. The yellow line is actual data, and the blue line is forecast. It seems like so precise, and there is a prediction after the actual data. Thank you.